Mm-hmm. Gotta add them all up. Okay, now this one's a little bit more common. Do you know when something's divisible by 5?
If it's 0 and
If
5?
it ends in a 0 or 5. Ends in 0 or 5. Well, again, pretty common. So, for example, if I had 3,435, it ends in a 5, so I know 5 can go into it. And these really come in handy when we have to do the trees later on in chapter 10.
Oh man, if I'd known any of this doing
The trees. And the trees weren't so big, the numbers weren't so big, but when there's something like that and you gotta break it down, it's nice to know the trick.
this. Yeah, it's so exasperating. You end up like trying, 10 different things.
Now 6, it's not as exciting. There is a rule. The rule is if 2 works and 3 works, then 6 works. So you kind of have to check 2 of them to know if one of them works.
So if the determination rules for 2 or 3, 2 and 3 work, then 6 work.
And when you're trying to think of like a GCF, even on this last test, if I think it was on your quiz. Let me see if I have some of these quiz that wasn't. Oh, boo. Let me just keep real quick. Hold on. I think it was the first problem.
Does it have to be 2 and 3 to, where it can be divisible by 2 or 3? Or are you saying if either one of them works, then 6 will work?
No, they both have to work. And I'll give you an example in a minute. I'm looking at your quiz that I gave you back yesterday. Those of you who, if I had it done yet, some of you didn't get it back yet. It said 12x plus 18y. And you factored out a 2 or you factored out a 3. Well, can 2 go into both of those numbers?
Yes.
Can 3 go into both
Yes.
of those numbers? Then that means there's a bigger number. 6 will also work, and 6 would have been the GCF. So that's kind of how you would look at the numbers to see if something works. And to give you an example, let's say we have, I think, 1,400. That will work. 1,428. How do I know if 2 can go into that?
Because it's even, the last number is
Because it's even. And if we add the digits up, we have 1 plus 4, that's 5, plus 2, 7, plus 8.
15.
Can 3 go into 15?
Mm-hmm.
Yep.
So 3 can go into this, meaning if I know 2 and 3 work, then 6 will do it.
Could you say that again?
Yeah. I know 2 can go into it because it's even. It ends in an 8. And then if I add all the digits up, I get 15, and I know 3 can go into 15, so I know 3 will also work. And if 2 and 3 work, then I know that 6 will work, and that would be the bigger number that you would want to use. So you just have to make sure, you have to do 2 steps to answer one question, but
So 2 into the last number and the other digits
all added up.
add up does 3.
Correct. That's correct. 7, not a fun trick. 8, not a fun trick. They take way too much time. 9, it's the same as 3. You add up all the digits. Add all the digits. So again, if I was to give you an example. $4,923. If I added all those digits, 4 plus 9 is 13, plus 2, 15, plus 3, 18. Can 9 go into 18?
Yep.
So 9 can go into that big number. And 3 can go into it, because 3 can go into 18. So little ways you can see if a number can go into it.
So for 9 and 3, they basically have the same rule.
Same exact rule. Yep. As long as that number can go into it.
And you skip 8, 7, and 8 because it's just 8.
Yeah, I mean, it's like 8 steps to do it. You have to do all this arithmetic. I'm like, I'd rather just get a calculator and see if it divides. So I just don't even show those. I don't even know them by heart. And then 10 is the most common one. What, how do you know?
Ends in 0?
Ends in 0. That's the one we like.
Except for 0.
So if I had any number, let's say 345, but it has to have a 0 on the end, then I know 10 can go into it.
Wouldn't 11 be anything that ends in 1 if it's a big number?
I don't know if that's true, but I know there is a rule for 11, but it's not that simple.
Oh.
You have to do, I know you have to like add the first 3, add the last 3, divide by, it's just complicated. So I don't do that. I just do these right here.